Good afternoon, everybody. Already time is very short, so I'm speaking very rapidly. Some of the thing already discussed. So this thing this thing is just overlapping all these things because all we know. So I just where I'm working, that is groundwater is a very problem. Though this is abundantly available, but some problem is going on due to abrupt abstraction than to recharge. So where some of the thing where the arsenic problem is going to be a problem, and some so in this to retard this situation, so some of the crop planning, some deficit irrigation practices, all these things going on. Although I am not going through this matter due to short times. Uh, so how to manage the groundwater with water management intervention so that crop productivity has been increased as well as nutrient use efficiency increased. Even the farmer, small marginal farmer, those for who we are working, that their income, employment opportunity has to be increased. This is our motto. So this is all you know, what are the water situations. I have in the morning session, afternoon session discuss, it just picture speak itself, so you know, all you know. So this is the situation worldwide. The Asian country is more suffering because of more abundant of people, population dominance in comparison availability of water resources. Things that is in comparison to world views, that is our India is the foremost in terms of water storage. And challenges, we have already discussed in the morning session that 6 challenges in respect of population, economic growth, productivity, industrialization, urbanization, climate change. So government interference, technology interventions, based on this which we have to make a balance between demand and supply so that the water resources to be utilized sustainably and more profitably and more and to maintain the environmental sustainability. So this is the things. So this is the picture where we know that this is our water scenario and their utilization patterns. So you know that is the very peculiar picture that worldwide view 4.2% water ability. Only we have 2.4% land, but we are mitigating 70% populations. But 63% of our land is rainfall situations. But what happened there? That 52% of our working forces are dependent on agriculture, and of which 80% are small and marginal farmers. So this is the picture at a glance you see. So you know that a present water scenario as well as in future water scenario, and water in every sector, irrigation water demand is going on, and I mean, agriculture is the main culprit or main user of the irrigation waters. But what happens due to demand from other sectors, allocation has been going to be decreasing in future. So some interventions to be developed and to be introduced in the farming community so that agriculture production has not to be suffered in any extent. So this is the scenario that water availability before independence, after independence. So we are going to the water stress to water scarcity situations. So one of the things that is the main slide of these things, that agriculture is the main user of water sector. So if we can increase the water use efficiency or water productivity, that means if we save the 1% water productivity, that means we can save 10% of water availability, and that can be utilized for other sector, for industry, or domestic purpose, or nature project recreation for all these things. So this is the thing, this is the pictorial views that what is going on from different plant period, different years, that we are, though India abundantly, that is we are plenty of water, but we are under scarcity. So this thing is going on, this picture speaks itself. But this is the valuable, not this is just skipping all these things, I have discussed all these things. So we have, this is the water, our actual potential, 140 potential, but still now we have developed 123 million hectare potential, and that is for irrigation purposes, and utilization that is 91. That means a huge gap, 42 million hectare area needs niche that is going to be under irrigation programs, if some interventions or oil plant technology to be introduced in the section. Because our water resources, what was generated, that has not been utilized sufficiently, only 74%. So this is the groundwater scenario. That is, we have developed 43.2 million meter of water, but it only utilization is 39.5. But there is a lot of water, groundwater remains in Indian subcontinents, but their utilization and absorption patterns that the technology has not generated up to that levels. So this is the very small things. This is how groundwater overdrafting is going on, how good area has going to be a critical, semi-critical, overall salinity. This picture speaks itself. So this is the thing. That is one of the things why water, we have developed water various medium, minor irrigation project. But that is irrigation efficiency is very, very less. That is 25 to 35%. Even groundwater 65 to 70%. So in that cases, particularly for agriculture, because they are major user of water, some intervention is necessary. Equitable distributions, that is unauthorized pumping, all these things, that is over-exploitation of groundwater, proper participative water management. This is some of the intervention have been delineated that to be introduced to use the water more efficiently, more economically. So some of the things that are how to increase the water use efficiency, the water productivity, this is the intervention is necessary from minor scale to medium scale to larger scales. This, if agriculture, this thing has to be introduced so that we irrigation water, that is a very precious resources, that has to be utilized more efficiently. So this is the general intervention has to be introduced, and there is a lot of technology in every aspect that to be adopted in the farmer scale. So, see, not necessary. You see some of the things that I am giving, that is in water sector, we are giving flooding irrigations, the 100% of irrigation. But we have examined all these things, as for example, broccoli. If I give some deficit irrigation, if we should not give 100% irrigation, if we give 80% irrigation by means of some micro irrigation, drip irrigation project. So 80% irrigations, that is sufficient to give as much as high yield than the optimum irrigation. Even that could save that is 20, 30% of water. So this is just a manipulation necessary. The water, what is the water ability and what technique to be introduced in the farming sector, so that both water efficiency to be increased, water savings to be increased, whatever the fertilizer that is precious resources, that has to be increased. Even some of the intervention that is polythene, that is how to conserve water to retard their evaporation losses. So some micro level planning, introduce some intervention can increase the yield, and that cost that also insists a substantial amount of water savings. So this same case is banana. That is 60%. We can save that 35% of water. That is based on climatically based irrigation. That is new technology intervention that to be introduced in a farmer scale or grassroots level, so that without interfering anything, without giving flood irrigation, surface irrigation, that is based on the water demand situation of the crop, we can save substantial amount of water that has to be utilized for other crop for irrigations. So same thing is guava. You see, we can save about 30 to 35% of water, and it also gives much higher quality, fruit quality. If we give irrigation, in drip irrigation, you know, that is only water, whatever the water as life that goes, that circulate around the periphery of the root zone. And water within the root zone, the water has been utilized by the crops, the nutrients that is soluble, that has been utilized. So what happened? Both water productivity, but nutrient productivity, use efficiency, that has been increased. This is the philosophy of all these things. And experimentally, we have proved all these matters. We can gladulous type, various type of flowers. That technology very, very beneficial and give the high economic return. That is the farmers, our main targets. So by this manipulation, by drip irrigation, gravity irrigation, the farmer income has been increased due to higher yield, higher quality attributes of the products. So this is the one of the option. The gravity drip irrigation or drip irrigation has to be introduced where the water is scarcity, where the water is very scarce levels. So even so it's not necessary. This is the things. That is some baby corn. This is a very has marketing demand of the crops. But under deficit irrigation, we are give much higher yield, that is quality. That is quality is also very good. So this is a great option for sweet corn and also some baby corns. This is the things. Another thing that is another option that we have to save the water. That is our motto. That is the World Water Day. That throughout the crop, we should not give irrigation throughout the stage of the crops. We should do what is the crop stages is very important. So this crop stage is very important. So introduce, we should have to identify that crop stages and give optimum irrigation in that stage. So by this way, we can give much higher yields. So we develop this type of irrigation scheduling that is in which stage what amount of water to be given. On various crop we have identified the various scheduling on various crop, and that give much higher yield and also much water savings. We also develop the irrigation calendar. That is due to climatic situation that cropping, sowing, planting all the delayed. So under delayed planting, what to be irrigation scheduling to be given so that water can be saved instead of flood irrigation throughout the crop stages. So this is some of the things, and also this is some resource conservation purposes. That is land leveling. Land leveling is the most important. If the land is undiluted, much water is lost. That is 30 to 35% water has been lost. So land leveling is compulsory. The crop residue management is very important to retard the evaporation loss. And also some of the raised bed sinking in the particularly waterlogged situation, some land shaping is necessary. So some of the technology I am giving, you see that is if the farmer is low-scale farmers, that is gravity drip irrigation, that is in a kitchen garden, that is the vegetable is the most remunerated crop. So by this phenomena, by this gravity drip irrigations, the huge amount of vegetable crop can be grown, and that give a much higher economic returns. This is the low-scale farmers, small type of farmers. They can adopt this kind of technology. And you see as a whole, what is various type of crops. That is due to gravity drip irrigation, you see tomato, onion, potato, cabbage, that is percentage 25 to 50% increase in yield, and also the water savings, that is 40 to 60% all this is. So without compromising yield of the crops, by manipulation of the drip technology or micro irrigation technology, we can increase the water, we can save a substantial amount of water. So this is the thing, that is gladiolas, that is also strawberry. You see, we have developed, this is the very good quality of strawberry we have developed, and these are the high marketing demands. And farmers come forward to adopt this technology, particularly strawberry, in their field. So some of the things that is, if there is that is agricultural point of view, that is waste of water you have taken, that our top idea. But where particularly saline belt, particularly in the arsenic prone area. So what happened? The farmers has no options. There is no desalination program or de-arsenic program. So in that case, we should just mix up, because farmers depended on agriculture for their return, for their livelihood. So in that case, we just mixing up the water so that dilution of the arsenic or salinity has to be reduced, and their load to the crops to be reduced substantially. So the farmer can get, until and unless new technology had been developed to desalinate or decontaminate the arsenic. So this is the thing that is on time scale, this has been developed. So multiple use of water, particularly in a waterlogged situation, land has to be raised, main crop to be grown, fish culture to be grown, even some of the horticulture, agriculture, this type. So multiple type of cropping, fishery, apiculture, all these things, dairy has to be given in a agriculture, total agricultural system, so that farmers is their beneficiary, so that the income has to be generated in spite of the ecological or the land disadvantaged situations. So zero tillage, this is some of the technology you have learned, that is pyrocropping. After particularly, the low-lying situation, if rice, after rice, there is substantial moisture remain there. So, but after that, what happens? After 1 month or 2 months, there is no water. So, in that period, after harvesting or within 1 month, there is no water. So, there is some crop that is sesame, pyra, that is sesame or lentil, some crop has been grown within that standing crop rice. This is called the pyra cropping. But within this system, within the residual system, one additional crop can be grown. So this kind of manipulation, agronomic manipulation, the brain manipulation has to be introduced to increase the farmer income and to increase the cropping intensity of that area. So some of that is not necessary. This is some pictorial view we have done. This is the experimental trials and also farmers trials. This is very good. Even turmeric, ginger, all kinds of crops. We have developed the water management technology, water saving technology. So these are some have been introduced in the farmers for the large scale adoptions. So these are the things. That is diversification of agriculture. That is pond has been used for fishery. That is a scaffold has been developed to make adoption, to make additional runner type of crops, and the raised bed has been used as a main crop, that is horticulture crop. So by this way, within a single time, 2 or 3 type of crop has been grown, simultaneously duckery, fishery, all, even some of the piggery has been developed in the same region. So land system, that is agriculture system, has a composite, not a single, not agriculture, all kinds of agriculture, horticulture, apiculture, pisciculture to be developed simultaneously. So the farmer incomes or the farming system income has to be included. So the farmer get interested in agriculture and other systems. So this is the thing, water harvesting, particularly in Purulia, that is very poor rainfall zones. And this has been, you see, that zone from no crops, this type of due to land manipulation, what is the situation has been developed. This picture speaks itself. So recommendation is key. Where the water is very scarce, some micro-irrigation technology to be introduced, or some water-based, the water demand, according to the water physiological demand of the crop, water to be given, and so there should be nexus between scientists and farmers, in between some of the NGO, and prior adoption of this technology, farmers programs to be initiated time and again, so the farmer get educated about the new technology and their accrued benefits. So all this technology, whatever we have developed, we have generated, that is translated in the vernacular language to the farming community. If adopted by some involvement of some other agency, there is a total picture, change of picture from gray to green. So thank you.